So for number one, going from 3 quarts into cups, as some of you already said, we don't have a direct translation from quarts to cups. So we've got to get rid of quarts first. What are we going to go to first? Pints. 1 quart is 2 pints. So the quarts have now canceled out, but now we're in pints, but we need to get to cups. So I'm going to put pints on bottom because we want to get rid of them too. And then we can go into cups. 1 pint is 2 cups. So the pints cancel out. So this is just going to tell us 3 times 3 is 6, times 3 is 12 cups. 3 times 2 times 2, I should say. Did I say times 3? Yeah, I'm sorry. It's early in the morning.
I know about early in the morning.
I'm like waking up at 3 o'clock to a car alarm. 5.2 liters going into milliliters. 3 spots to the right. So that's 5,200 milliliters. By the way, get used to seeing 5,200 like that written just like this with no comma. They just put an extra half space in there. The reason being is in a lot of foreign countries, like 2.7 is written like this. They use a comma instead of a decimal point. It's the metric way of writing things is with a comma instead of a decimal point. So to avoid confusing this with 5.2, we started using the half space. And here I'm going to keep using commas because I'm not precise enough with my writing to make it look like a half space. But yeah, just be prepared for that. You may sometimes see commas that are really decimal points for what we would be looking at. 2,900 cubic centimeters into liters. Do you remember how to do this? 2,900 cubic centimeters or centimeters cubed is actually the same as 2,900 milliliters. Cubic centimeter or centimeter cubed is a milliliter. So then from milliliters to liters, the decimal point goes 3 spots to the left. That's 2.9 liters. 16 quarts into gallons. Which one's bigger, a quart or a gallon? Gallon. So it's 1 gallon. How many quarts go in 1 gallon? 4. So the quarts cancel out. The 4 is on bottom, so it's 16 divided by 4 is 4 gallons. Now down here are cubic feet to gallons. 4 cubic feet over 1. We're going to put cubic feet on bottom, gallons on top. Anybody remember the relationship between cubic feet and gallons? 1 cubic foot is 7.48 gallons. So what is that, 29.92 gallons? And finally, 6 quarts into cubic inches. Well, first we have to go from quarts into gallons. 1 gallon is 4 quarts. I'm going to go ahead and complete this conversion first. Quarts, 6 over 4 is 1.5 gallons. And then I'll go ahead and I'll do the conversion from gallons, 1.5 gallons, over 1. Put gallons on bottom, cubic inches on top. 1 gallon is approximately 231 cubic inches. So that's 1.5 times 231, giving us 346.5. Any questions? Okay. Well, today we're going to talk about weight and mass. So before we have that discussion, we need to discuss what is the difference between weight and mass. Weight measures the force of gravity on an object. Mass is the measure of the amount of matter. In an object. In other words, how many particles, how many atoms are in that make up that object. The difference is in how they're measured. Weight is measured usually with a spring and by how much it is stretched or distorted by the force that gravity is pulling on an object. So we'll have a scale which will look like this. And that scale will have, let's do this right. An indicator on it, a needle like this. And it's labeled with, well, the reason they call it a scale is because it's labeled with a scale. So there's nothing on here right now, so that needle would be at 0, then 1, 2, 3, whatever. When we hang an object on it, that spring is going to stretch out. So that needle is going to move. It will no longer be there. It might move down here. So the amount that spring stretches indicates the amount of force that gravity is applying to that object. The way mass is measured is with a balance. So this is called a scale. Mass is measured with a balance. Think like a teeter-totter. Put two people of equal size on each side, it sits there. You can float in midair, right? We take the object that we're trying to measure, we put it on one side. And then we take objects of known mass and put them on the other side. Trying to make that look like the little prefab masses they have. And when it balances, whatever mass is over here is equal to the mass that's over here. Now you might wonder, well, how is that different? Well, mass is a constant for an object. If I go to the moon, gravity is different. There's about 1/6 the gravity on the moon as there is on Earth. Well, if I go to the moon, the amount of force that's going to be pulled on this is going to change. So that spring isn't going to stretch as much. So that might be somewhere up in here is where my indicator would end up at. It won't stretch as much, so the weight changes. However, on the moon, the force of gravity on my object changes, it's less, but the force of gravity on my known mass is going to change as well. So it's still going to balance the same known mass. So mass will not change. Mass does not depend on the force of gravity. Now, on Earth, gravity is pretty much the same everywhere on the planet. It's actually slightly less at the equator and slightly more at the poles. It's significantly, it's even more decreased at the equator if you're on a mountain at the equator. But anyway, it's a very, very, very slight difference. So it's close enough that we consider gravity on Earth to be a constant. So on Earth, we kind of use weight and mass interchangeably. Now the reason I bring this up is in the standard system, we tend to measure weight. The units that we use most often measure weight. In the metric system, we tend to measure mass. Those are more popular units. We do have units of mass in the standard system and units of weight in the metric system. It's just most of us have never heard of them. It's a little bit sloppy when we talk about, in a couple days, we'll talk about converting from standard to metric and metric to standard. For length, we're converting lengths, and for capacities, we're converting capacities. But when it gets to weight, we're converting a weight into a mass, or a mass into a weight if we're going the other direction. So in the standard system, we typically do look at weight. And let's start out with a large weight. If we want to measure something really big, we look at a ton. How big is a ton? 2,000 pounds is what we typically think of as a ton. This is technically what is called one net or short ton. 99.99% of the time, when you hear the word ton, they are talking about a short ton or a net ton. Now, if there's a net or a short ton, it implies that there is something called a gross or a long ton. A gross ton or a long ton is 2,240 pounds. Well, why the difference? Well, the difference, the ton was originally used for measuring grain. And if you're buying and selling grain, if you're trying to measure grain, putting it on a scale, you try to put 2,000 pounds of grain or a ton of grain on a scale, it's not going to sit there by itself. It's just going to run off the sides. It has to be held in a container. The container that typically held a ton of grain weighed about 240 pounds. So if you were measuring the grain in its container, it was a gross ton, 2,240 pounds. Without the container, it netted 2,000 pounds. Think of your paycheck. If you work for 40 hours and you earn $12 an hour, you've earned $480, 12 times 40. That would be your gross. That's the full amount. Did you get 480 bucks? No, they take out taxes and all sorts of other crap. You might get $300 out of that 480. That would be the net, the amount you actually get. For our purposes, we will never use the gross ton in this class. I just wanted you to be aware that there is one. It does exist. So if you ever hear the term gross ton, you know that it is slightly different. Not to be confused with the term gross. The term gross is actually a number. It's a dozen or 144 items. A metric ton we'll get to, that's actually 1,000 kilograms or a megagram. So smaller than a pound. By the way, the abbreviation for pound is LB. Now it makes sense to have used PD for pound, but in the bookkeeping for buying and selling grain, PD was already used as the abbreviation for paid. And they didn't want to confuse pounds with paid. So they used the Latin word for pound, which is libra. So that's where the LB comes from. Smaller than a pound, we have ounces. How many ounces are in a pound? 16 ounces. The ounce is abbreviated OZ. OZ comes from the Latin word for ounce as well. I don't remember what that Latin word is right now, but they could have just used OU, but they chose to stick with the Latin unless they did it for pounds. Smaller than an ounce, there's something called a dram. There are 16 drams in an ounce. A dram sounds metric, but it is not. It is a unit, one of the original apothecary units. You might get prescribed an eighth of a dram of medication or a quarter of a dram of medication. There was another unit that was very common called a grain. 7,000 grains is equal to 1 pound. Grains were used for measuring out medication as well. They would prescribe 300 grains of medication or whatever. For guns, have any of you ever reloaded your own shells for guns? You see that those are measured out in grains. Dairy industry, there's something called a hundredweight. Of course, you guys are used to using a hundredweight as what? 100 pounds, right? So you're talking about, $14 per hundredweight or whatever you're going to get for your milk. Technically, a hundredweight was not originally 100 pounds. It was actually originally 8 stones, and a stone is 14 pounds. So we do the math. 14 times 8 is actually 112 pounds. but they have adjusted that. We're not going to get into too many of the other odd units of weight. There are a few of them out there, like a hogshead and stuff like that. But I do want to mention, if you guys listen to the news at all, you hear, gold is up to $1,700 per ounce or whatever. What you're hearing there is not our typical pounds and ounces. We had mentioned when we talked about length, King Edward declaring that his thumb and his foot and his arm and everything else were going to be the official units used. And we talked about how different rulers in different areas made the same declaration. So the yard and the foot and the inch were not standard from one country to another. The same happened with pounds and ounces. They were not standard from one country to another. This is the British pound and ounce that we use. And actually there's something called the British Imperial pound that's slightly different from our pound. But different countries, different parts of the world, the pound and the ounce was different from ours. Well, precious metals, gold, silver, and others, the world center for buying and selling those was established on the island of Troy. That was originally one of the richest areas in the world, and that's where gold and silver traditionally was traded. So we still to this day buy and sell precious metals in troy units. In troy measure, 1 troy pound is about 0.82 to 0.83 regular pounds. So a troy pound is actually smaller than a regular pound. However, 1 troy pound contains only 12 troy ounces. So a troy ounce is actually a little bit bigger than our standard ounce. We, again, will never have to do these in this class, but I wanted to show them to you so you're exposed, so you know that when you hear that on the news, you're not talking about our standard ounce and pound.
I have a $1 coin.
Yep.
0.999% troy ounce.
Or 0.999 ounces silver.
Yeah.
That's probably worth, silver, depending, it's usually, normally historically it's set around like $7 or $8 an ounce. But it was up to like $70 an ounce for a while there. I'm not sure where it's sitting now.
I got it for free, so.
Well, yeah, nothing wrong with that. Yeah, I have it's like a half-ounce copper coin, pure copper, which copper was getting pretty pricey for a while too. A penny was worth they switched over now. Pennies just have a very thin layer of copper. They're actually zinc with a real thin layer of copper over them. But prior to 1982, those were solid copper. The amount of copper in those older pennies is like 1 3/4 cents worth of copper. Almost 2 cents worth of copper in those pennies. In fact, there have been times where it's been close to 3 cents worth of copper. But yeah, the silver coins, if you hit it at the right time, you can make out pretty well with them. So anyway, let's take a look at our metric units. Now in metric, I forgot to mention, by the way, standard, those were standard weights, standard mass. The unit of mass in the standard measuring system is the slug. Anybody ever heard of a slug? 1 slug is 32 pounds. That's at Earth's gravity. 1 slug would weigh 32 pounds on Earth, I should say. I need to specify that translation. So in the metric system, we tend to focus on mass. Before I forget, I'm going to put the metric unit of weight up there. Metric weight. The metric unit of weight is the Newton. Newton, yeah. 1 kilogram is 9.8 newtons. Again, that's on Earth. On Earth, 1 kilogram of mass would weigh 9.8 newtons. So anyway, We're going to focus on our standard units. Gram, abbreviated with just a G, is the unit of mass. A gram is about the mass of a large paper clip. Actually, not even a large, a medium-sized paper clip is 1 gram. So it's kind of a small unit. Then we still have decigram, centigram, and milligram. Just like in our other units, we use the main unit. We don't use deci and centa for hardly anything, but we use milligram. We do get down into micrograms, into medical testing and stuff like that, but we're not going to go down there for this right now. Larger, we have decagram, D-A-G, hectogram, and kilogram. So again, we use kilogram, but we don't use heca and deca hardly at all. 1 kilogram, it's actually like 2.208 pounds or 2.21 pounds. We're just going to say approximately 2.2 pounds in a kilogram. So a kilogram, a little bit more than twice a pound, but it's the closest thing we have to a pound in the metric system. A gram is considerably smaller than a pound, actually considerably smaller than an ounce. It's like 28.4 grams in an ounce. So it's considerably smaller than an ounce. If we keep going larger, if you recall our units that we had, a kilogram is 1,000 grams. The next one up, we went up to 1,000,000. So 1,000,000 grams would be a megagram, capital M, G, megagram. A megagram, or 1,000 kilograms, 1,000,000 grams or 1,000 kilograms is what we define to be a metric ton. And that metric ton is approximately 2,208 pounds. So it's just over 2,200 pounds. Our conversions in the metric mass is exactly like they were for any other metric unit. Just move the decimal point according to the spots on the chart. And as we had mentioned with our capacity yesterday, we had mentioned that the 1 milliliter was 1 centimeter by 1 centimeter by 1 centimeter, or 1 centimeter cubed, 1 cubic centimeter. 1 gram is defined to be the mass of 1 cubic centimeter or 1 milliliter of water. So with that information, we can actually do some pretty interesting conversions here. If I have a tank, and to keep it simple, I'm going to use a rectangular tank. Let's say that this tank, we're going to measure it as 80 centimeters by 50 centimeters by 20 centimeters. To find the volume of that tank, 80 centimeters times 50 centimeters times 20 centimeters. That's 20 centimeters. What am I going to get? $80,000 centimeters cubed? Sound right? What would be the mass of the water contained in that tank? Well, we convert centimeters cubed into milliliters. How many milliliters would that be? 80,000. We can convert milliliters into grams. How many grams of what would that be if that was water? 80,000. Well, let's convert it into kilograms. To get from grams to kilograms, we just go just to the left. That's 80 kilograms of water. 80 kilograms would be like 22, 23 gallons. Or no, sorry, 80 kilograms. 80 milliliters would be 80 liters, right? 80 liters, yeah, that's approximately 22. Let me do it exactly for you. A gram was defined to be the mass of 1 milliliter of water. So if this is water, that would be 80.
A gram is a weight, right?
Yeah, gram is a mass. But
Why is it divided by 3.785?
there's 3.785 liters in a gallon. So 80 liters is 21.14 gallons, about just over 21 gallons.
So how much does that water weigh?
So that water weighs 80 kilograms of mass, or if we were converting it into standard, that would be about 176 pounds. So times 2.2 takes into pounds. As we had mentioned, we tend to measure weight in the standard system and mass in the metric system. It's just a way of looking at things. The difference is that force of gravity, but on Earth, gravity is pretty constant, so we're not going to worry about the conversion.
Okay.
We'll just jump back and forth between mass and weight.
So
Okay, what's
mass
that?
and weight is the same thing if you're on Earth?
Yeah, the difference is mass does not change if gravity changes, and weight does change if gravity changes. So if you go to a different planet where gravity is significantly different, then it makes a difference. Let's say on Earth, gravity is slightly less at the equator than it is at the North and South Pole, but not enough that it makes a huge difference for us.
You won't float away?
You're not going to float away, no. But someone my size would probably be 10 to 15 pounds difference in weight between the North Pole and the equator.
Would you be heavier at the equator?
I would be heavier at the North Pole. I'd probably be, from here, I'd probably be 4 to 5 pounds heavier at the North Pole. Probably between 8 to 10 pounds lighter at the equator. But it's still, I mean, you're looking at a 5% difference. So it's not huge. In those packets we've been working out of, on page 238, 51 through 56 deals with standard weights. On page 266, 49 through 54 deals with metric masses. So it's just the next section on each of the pages of this packet.